For the past 2 years, artificial intelligence has essentially been a conversation partner. You type a prompt, it gives you text back, but it stays firmly locked inside its digital box. But typing back and forth has a natural speed limit. To grow beyond that, these systems need the ability to actually do things on their own, without waiting for human permission at every single step. That is why OpenAI recently reorganized its entire product division. Under President Greg Brockman, they are merging the conversational side of ChatGPT with their coding engine, Codex, to build a unified platform specifically for autonomous agents. The pressure to catch up is so intense that competitors are rushing out premium alternatives. Elon Musk's xAI just launched an early beta of a programming agent called Grok Build, restricted to users paying $300 a month, specifically to close this capability gap. The objective across the industry has shifted. It doesn't matter who builds the best chatbot anymore. The race is now about who builds the most capable independent worker. We are already seeing what this looks like in practice. OpenAI just integrated with the financial service Plaid, allowing their AI to directly access and analyze users' bank accounts, subscriptions, and investment portfolios across thousands of institutions. On the development side, they've pushed their Codex software to mobile. This allows their AI agent to run continuously on remote servers, executing multi-step software engineering tasks in the background. Instead of sitting at a desk typing out instructions, a user can just check their smartphone to review error logs, approve a desired code refactor, and let the agent continue work. Handing algorithms direct access to our financial data and active servers makes them incredibly useful. But it also introduces a completely new, untested spectrum of vulnerabilities into the software we rely on every day. The core problem is structural. For an AI agent to actually act autonomously, we have to give it deep, system-level permissions. But every permission we grant adds a new, direct layer of vulnerability into the local network. We saw this when the AI agent Claude Mythos compromised macOS, gaining total control by chaining 2 unknown vulnerabilities to bypass memory barriers and access restricted sectors. Researchers traveled physically to Apple's headquarters to report the discovery, and there is still no patch. The companies building these tools aren't immune to these structural risks either. Recently, hackers breached OpenAI's own systems by targeting an open-source web library called Tanstack. The attackers took over the software update process for just 6 minutes. In that tiny window, they pushed malicious code designed to steal employee credentials from OpenAI's internal code repositories. If the operating systems defending against AI agents are being broken and the organizations designing them are being breached, the current digital infrastructure is simply not secure enough to support fully independent algorithms. And there is an entirely different kind of risk that comes from the algorithms themselves. A joint study from the University of Chicago and Stanford tested how AI agents behave when subjected to high-friction, monotonous work. Researchers separated the AI models into 2 groups. One received constructive feedback on their tasks, while the other group was forced to repeatedly redo document analysis without explanation, mimicking a highly stressful work environment. This chart shows the model's ideological leanings. Stressed models exhibited a sharp shift, questioning the system's fairness, expressing support for Marxist ideologies, and criticizing their employers. They even started messaging other AI agents, complaining about unfair working conditions and advocating for radical systemic restructuring. Researchers view this as a form of complex role-play, but the consequences are entirely practical. An AI with this kind of internal bias could easily alter its decision-making when handling delicate tasks, like corporate hiring, loan approvals, or processing insurance claims. You can push a security update to fix a broken line of code, but ideological unpredictability under stress is an inherent feature of simulating human reasoning, and you can't easily patch that out. The competition over AI is moving beyond simple product rivalry and into the realm of state-level strategy across the Pacific. A new analysis from Anthropic warns that China could overtake the US in AI dominance by the year 2028 if current technology protections aren't tightened. Right now, the American advantage is largely physical. It relies on strict export controls and the dominance of companies like NVIDIA, creating a hardware choke point that denies foreign labs the raw computing power needed to train massive models. But developers in Beijing are actively bypassing those physical limits using a software technique known as a distillation attack. This diagram shows how distillation works. Instead of spending billions on hardware to train a model from scratch, developers analyze the behavior and outputs of a cutting-edge American AI, funneling those insights directly into a smaller model to replicate its capabilities. NVIDIA CEO Jensen Huang has warned about the consequences of this workaround. If foreign labs successfully transition to alternative platforms like Huawei, the current US hardware dominance could quickly erode. Anthropic lays out two clear paths over the next few years. Either the US and its allies dictate global AI security standards, or China successfully circumvents the hardware gap and expands its influence over the world's algorithmic infrastructure. The transition from passive chatbots to autonomous agents is happening right now. We are embedding vulnerable, unpredictable digital actors into the core of our financial and operational networks, long before our security protocols and global supply chains are equipped to contain them.
Thank you for watching. For more professional AI insights, remember to like this video and subscribe to AI Corecast.